vintage Tektronix 442 oscilloscope. This came out of a garage full of stuff that was going in the trash. I don't really need this, but I didn't want to see it just go to the dump. I believe this is about a 35 megahertz scope. So by today's standards, a total boat anchor, but more than sufficient for old TVs. It's totally dead, doesn't power up, no green power light. 2-channel. I am by no means any kind of expert or have very little experience repairing test equipment. I'm sure I can diagnose it. That's what this video is going to be about. Watch me figure it out. So it's using 6.8 watts. We'll flip the power switch here. Ooh, turning it off, the power goes down to 0 watts. So that's probably our transformer, our power transformer only, primary. Power factor is 0.70, so yeah, it's probably just a transformer. I take the fuse out, it goes to 0 watts, so the fuse is not open, the fuse is good. So I'm going to open it up and let's look at what's on the inside. At least, even if I can't fix it, we can still look at it. Might be kind of interesting. Okay, well, 4 screws and I am in. And the first thing I notice, just visually, is that right there. Right? It's baked. And we like baked. And, ooh, that looks baked. What is that, a Sprague Atom? I bet it's still good. Ooh, that looks baked too. Look at that there, isn't that cute? A roll of coax. I'm not even gonna assume what that's for. We got another fuse here. Watch me break it. Stand by. This was not a cheap unit, was it? So this is definitely the power supply, as it says, and this over here is probably the scope portion. Like I say, I can kind of use the thing sometimes, sort of a little bit, but I'm not by no means a buff on vintage test equipment repair. Wow, we got more fuses there. And it looks like this has definitely been worked on before. Look at that screw, how stripped out it is. We've got all our regulator ICs. I'm sure somebody is yelling, just recap it and it'll work perfect. Yeah, I don't think so. That does look crispy though. And so do these, but that doesn't mean anything. I think channel 2 just failed here. Crap, well that almost makes it just worth trash can material. Plastic, gotta love it. When it gets old, it just disintegrates. So the power switch here goes to this board, which has got this thing that's cooked. Let's address this first. Just absolutely just layers of boards. This thing is highly American made. Switchcraft. This is almost like some kind of mil-spec piece of equipment. Trying to get it apart without breaking any plastic. Okay, let's do some voltage checks here. So this is a resistor. These two big leads. So on this side we have 82.6 volts. On this side we have 93.5, so it's definitely not open. Let's see the smaller one. We get 31.72 volts here, and on this side we have 82.5. So unfortunately it doesn't, I guess this thing here is the high voltage power supply for the CRT. So I'm not sure if the problem's on this board. I love all these glass capacitors on here. Okay, it would be nice if they'd give you voltages on the rail. You know, that would be real nice. But of course, they probably don't want you fixing your own crap, so we're going to have to... And I believe the schematics are available for all this stuff online, but yeah, I'm too damn lazy to go search for it. I'm going to just measure some voltages across these capacitors. On this one here, we got 200 millivolts. I don't think that's right. That does not seem right. I'm going to go to this one. These are the big B plus caps. Okay, I got 1 volt. 1 volt across the main filter. There's another big filter up here. Let me check that one. Okay, this one here has 145 volts across it. Holy crap. If that's a fuse, it has 300 millivolts across it. That seems kind of high. This fuse ohms out good. I'm not sure what's going on with these two, though. I would think we'd be measuring 0 volts across them if they were, you know, good. Okay, we have 700 millivolts across this capacitor. We have 94 volts across this capacitor. So it's like the high voltage side is there, but the low voltage side is not. I'm sure this uses 5 and 12 volts, or positive and negative 5 volts. I'm going to depower it and check those fuses. Well, if that is in fact a fuse, it's measuring 59K. And if that's a fuse, it's measuring 4 megs. Alright, well here's the deal with this. The power transformer is here. These two fuses are on the secondary coming out of the power transformer. Then it comes over here to the bridge rectifier. And then the low voltage. What's interesting is I'm only getting 1.2 volts AC out of the power transformer. Maybe I need to change the battery in this meter. Do we think it's time? I've only been milking this one on dead for like 3 months. Well, that made a hell of a difference. Changing that, now we got 25 volts AC across those fuses. So there's a lesson. I guess when the battery gets low in this, the DC and ohms works fine, but the AC measurement craps out. Oh well. So let's measure the drop across that fuse, 11.8 volts. Let's measure the drop across this fuse, 12.49 volts. Okay, that looks good. Geez, I'm my own worst enemy sometimes. So, why did these fuses blow? And I can get Pico fuses and put them in there. That's no big deal. But why did these fuses blow? Do we have a shorted bridge? Do we have a shorted capacitor? Do we have a shorted regulator? Or do we have something on the outside, like one of these beautiful tantalum teardrops that is shorted? I'm going to start by checking these diodes. That one's good. So, let's see. Always start with the simple stuff first, right? That one looks good. God, look at those. They look like old Motorola American-made diodes, rectifier diodes. That one's good. That one looks good. Let's do this clinky dinkler here. Not shorted. It's creeping up kind of slow, but it's not shorted. Let's do this one here. That could be a diode or one of the regulators. This is kind of interesting. Why these fuses, and why would both of them blow? Why not just one of them? Just the sheer elegance and American flavor of the build of this thing. And is this a date code right here? 7806, 7805. Just pure red, white, and blue. I guess you could call it sloppy construction. But most of these I can tell are American-made components. Some of the chips aren't, but this stuff is just, that's not, of course. This is a, might have been replaced right here. That's a Nippon Kimicon. This is a Sprague. These are Spragues. Just gorgeous. Some would call it chaotic, but I call it gorgeous. It's just, and all the metal, aluminum, and the heat sinking, and all the brushed aluminum, and nuts and bolts holding everything together. It's just don't see stuff like this anymore. Alright, here's what I'm going to do just to make everybody shriek and shudder. I'm just going to bypass these fuses. I was going to use some automotive bulbs, but man, just screw it. If it blows up, it blows up. I already have enough of these scopes. So this is on AC amps. Here we go. I'm going to jump one. Now, I wouldn't expect... Wow. 1.4 amps, really? This is where we get the thermal meter out and see what's shorted. Okay, I'm gonna jump the other one. Same thing, 1.5 amps. That's right at the limit of this thing. So I'm going to jump both of them now. I mean, let's get this party fired up. This is so amateur. Crap. Trying to do this crap one-handed is just like... Okay, stand by. I'm going to... Oh, well, if I get both of them in circuit, I get one... Do I have a green... I have a green light over here. Stand by. So if I get both of them, I get 1 amp on each leg, which... And this guy here is getting warm. We have a dim on light. Let me see, intensity. It does not appear. I don't think we have any high voltage. I don't know that for sure. Beam finder. Position. Where's the vertical position? Let's see, we want this on AC channel 1. And pushing, yeah, it wouldn't surprise me if there was another problem that blew those fuses. We're down to 800 milliamps. I guess these capacitors are reforming or something, but why is there no beam unless there's no high voltage? Is the filament glowing? Oh, I think we have a capacitor failure. We have foam. We have bubbles. I hear something crackling and I think to myself, well, is that the high voltage? No, it's a foaming capacitor. Isn't that elegant? But that, it's not getting warm, it's just foaming. God, I love to torture the capacitor changers, don't I? Nothing is excessively hot here. I don't think I've ever seen an electrolytic squirt out foam before. That's a new one for me. Rock on, Sprague Atom. Pure class. I don't see any evidence of illumination from this CRT whatsoever. None. It's like the heater's burned out, or it's not warm at all, or it's not getting heater voltage. Yeah, I should definitely see a filament in there, at least I think. And I don't see any kind of glow or any kind of heat. Well, usually, and I say usually, filaments are brown. And so if we go to, this is pin 1 and 14, we have brown. And if I measure the ohms across pin 1 and 14, I have 15 ohms. So maybe this is like a 12 volt CRT, so that would be about an amp. I'm now getting buried in this a lot deeper than I wanted. This CRT gets its voltage, like a lot of modern plastic crap TVs, right off the flyback, if you want to call it a flyback. 6.8 volts elevated to 2000, so they have it tied to the cathode here. I guess that would prevent a heater to cathode short to have it, or it arcing out internally. And this circuit just looks like a standalone high voltage generator. Here we've got a driver transistor, or like a horizontal output with a damper diode. And I don't know if this must be the oscillator circuit right here. And it just looks like kind of a big feedback oscillator. It doesn't really have any sync, if I'm looking at this right. So this thing here is basically just a 2 kilovolt generator for the CRT. And then of course your sweep signals are fed in through these plates in the CRT. And yes, these service manuals are extremely readily available and they are very, very, very thorough. So I bet you there's a full description here. A 50 kilohertz. See, I'd have to read this whole thing. I'm getting buried in this a lot deeper than I wanted to, but at this point I can't stand not to see it work, or at least diagnose it down to where I can condemn something. So yeah, let me research this. Going back to the original problem, here are the two fuses that were blown. One of these two capacitors is the one that was foaming. So basically what this is this is a positive and negative 8-volt regulated supply. So you get, out of this side of it, you get positive 8 volts. Out of this side of it, you get negative 8 volts. We should start by checking these two rails here and seeing if they're in fact positive and negative 8 volts. Maybe there's something else going on here besides the foaming capacitor that caused this thing to blow. Maybe one of these transistors is shorted or open. I have absolutely no issue with recapping this thing if it's working. And I can tell you now that the odds of the caps keeping it from working are very low. So looking at B plus right here, we have positive 7.97 volts. Looking at B minus, we have negative 7.98 volts. So our regulation is working. This board is working. Maybe those fuses popped because something on the high voltage generation circuit shorted, or maybe the fuses popped because the capacitors were shorted and someone turned it on without, and they didn't reform. Now they've kind of reformed and have, you know, gone up in resistance a little bit. So the power supply is not an issue. We have an issue on this high voltage board here. Should have 100 volts through 150 ohm to pin 4. This is the high voltage generator. And then that goes to the collector of C458. Got a 430 ohm off the base. So let's start. I wonder if this right here is that resistor that's all burnt, the first thing I saw in the video. Okay, here's the high voltage transformer, like the flyback. I wonder what this thing is right here. High Voltage Devices Incorporated, made in USA. So I wonder if this is the main high voltage. So this must be the main high voltage source. Oh, okay, it is. It comes up here to this. So this might be like a tripler. Gee, I wonder if that was bad. These are our transistors down here. This red transistor right here is the high voltage driver transistor, and I'm measuring. See, if I measure the collector, it's pretty sloppy. I'm getting 128 volts. If I measure the base, I'm getting negative 500 millivolts. Testing this transistor and circuit, which is kind of a worthless test, but you should have two diode junctions, base to emitter and base to collector. We got those. So that right there is base to collector, and that right there, that is base to emitter. So we have two diode junctions here. So it doesn't appear that that's blown open and it's not shorted. I believe those two transistors right there, those two transistors are the oscillator circuit, and that is the tantalum capacitor, and that is, it's not shorted. Okay, well, I'm running this little squiggy spoimler with my flyback tester, and it's working. It's not shorted, but it's starting to rain, and we got a big storm moving in, so I'm going to put this away and come back to it. That indicates that what that's doing is it's at a low level powering up the high voltage part of this transformer, so nothing's shorted, at least not at a low level. So we got a problem on the drive side, not the secondary. So that's good. Okay, let's spend a few more minutes on this since we're rolling out on Adult Diaper Lovers International Center for Strategic Diagnostic Precision. Before it started raining, which it stopped, I used my tester to feed basically a test signal in here simulating the horizontal output. And it didn't show a short. So why is this thing not running? Why is this thing not oscillating? Well, I read the manual, and the manual doesn't go into much detail, but it says if there's no high voltage, that suspect one of the 3 transistors. So again, there's not much to this. There's that's the red. No. Okay, let's try not to do that again. So we got Q458, which is the red transistor that I tested. Now it does say in this manual the only real test for a transistor is substitution. And you know, this is a simple circuit, but sometimes these simple circuits will really drive you crazy. So I can't figure out, I'm not smart enough to understand if this is regulation or if this is oscillation. It looks almost more like a regulation circuit to me that comes off of the secondary and feeds back and controls the bias on that, thus regulating the high voltage. But what do I know? Anyway, we want to take a look at this Q446 and Q454. Okay, at this point here it suggests we should have 7.6 volts. 7.6 volts. Here it suggests we should have 7 volts. We have 6.85. But again, it's not running, so I don't know how valid this would be. Other than if one of these was shorted or open, you'd think it would be way off. That one right there looks like 0.8. We'll check that. Well, wait a minute. What am I doing wrong? Am I not reading this right? Because I'm measuring 7.56 there. Unless... Stand by. Yeah, I have 7.6 there. How is that possible? Unless this is a typo. And I have 7.6 on both sides of this. But I don't remember having 7.6 on this base. I do have 7.6 on the base. How's that even possible unless this transistor's blown out? Because this junction right here would be about 500 millivolts, and I thought we checked that. What am I doing wrong? Okay, what the hell is going on here? I'm measuring from the emitter to the chassis right now, and I've got 1 volt. Does this thing get its ground? The emitter is supposed to be grounded. Does it get its ground through the screws? That would be a stupid design. Okay, where the hell does this thing get its ground? That's the emitter. It comes to there. There was no screw in there. Then it comes to over here to the transformer. And then it comes to these 3 things. And it comes up here to this resistor. And it comes to this. Okay, well, the damper diode is right there. So I don't believe that connects to that lead off the transformer. And then those 3 green things, those are just filters for the information coming in here. So where it goes to the transformer right there, and those 3 filters, you can see how it hooks to the 3 leads, the capacitors do. So where the hell did this thing ever get its ground from? What am I missing here? All right, well, I got a flashlight and I started to trace this, and this missing ground is the fault of my own doing. I had that screw taken out right there, and that screw, it relies on that screw for the ground. If you follow it, it comes onto the top of the board, and then it runs to that screw. And I think it's a stupid design, and you don't hear me say that often. Running grounds through eyelets and screws and stakes is a real problem causer. So let's see what it does now. All right, well, now we got like 0.1 here. We got a negative voltage on the other side, which would almost indicate that it's running. I would think if we had high voltage, these two little neon things would be lighting up. So speaking of that, watch when I turn the power off. Watch the little neon things. See them there? So why will the damn thing not run on its own? Interesting that I have negative 0.4 on one side of this resistor and positive 0.9 on the other side. That almost suggests that this thing is running. According to this should have 2 kilovolts here on C466. I'm going to use the high voltage probe that came with the meter, and we're going to probe it here if I can get to it. This is not... Interesting, when I touch it on there, that light flickers. Wow. 1.9 kilovolts? Is that right? So do I have 2 kilovolts here? Why is this thing not working? Okay, here's the tripler. And we should have 10 kilovolts there, but unfortunately I really can't access that to measure it. But why is the CRT filament not lighting up? I mean, we clearly have 2 kilovolts here. What am I missing? Okay, now I'm measuring the filament voltage, which should be 6.3 with 2000 volts. And I think I've got everything isolated far enough to do it. And those 2 brown wires coming out of the transformer are the 2.5 kilovolts. Let me see if I could cremate the meter. We've got 6.1 volts. Why the hell is the CRT not? Why is this thing not working? What am I missing here? Well, I don't know what I did. I don't know what I did, but it's working now. Let's see, where's my vertical position? Vertical position. Standby. Oh, wait, here we go. It's working now. What did I do to this thing? Was it that screw was loose the whole time? I don't know if this will show, but I got a little bit of a rolling thing at the bottom. And I think that's because this capacitor here is just done. I measure the voltage across this one. It's like 1.5, and I measure this one. It's 2.2. So AC, not DC. So there's a 1.5 volts of AC ripple across this one. Look at the freaking caustic crust that's leaked out of this thing. So just in the interest of making the video, I didn't have a 2200, so I put 2 1000s in parallel. And that definitely got rid of our little squiggly Daimler at the bottom of the Skorkel Snorfler. Okay, these are called Pico Fuses, these little green ones that I just paralleled across the top of the old glass ones. I think this thing might, since I'm so buried in it, the next time I do DigiKey, I might order new capacitors for it. There's not that many of them. I I started to pull this apart so I can figure out if I want to super glue it or try and get a new shaft and then re-glue the knob. I have to figure out how to get the knob out of there. And I'd like to clean these controls, but everything is all sealed. I believe this probe adjust is somewhat like a calibrate. So it just gives you a fixed voltage square wave. And you can see there, it looks very nice. I mean, it's an old analog scope, you know, it's a 30 megahertz analog scope, but it looks like it's working quite well. So maybe we'll use it in an upcoming repair video. It actually seems very stable. I would like to repair these channel 2 knobs. Yeah, that looks like a Tektronix 442 oscilloscope repair. Should I turn that upside down so the Google image recognition can get that in there, get that indexed? Tektronix 442 oscilloscope. I don't know what happened with why the high voltage in that started working, and you can see the filament glowing now. The only thing I can think of was that screw was loose, that ground screw. I mean, we definitely, most likely, we had a leaky capacitor here that blew the fuses when, I don't think it did it when I powered it up, but the people that were at the garage told me that they plugged it in and it didn't do anything. So maybe it had been sitting for 20 years and they plugged it in, but it's working now.